Hey everybody, this is Mr. Beckstrom, and today I'm taking a look at an example from section 7.4, and it says find z1 times z2 and z1 divided by z2 for the following pair of complex numbers using the trigonometric form. Write the answers in the form a plus bi, and they give us that z1 is equal to 3 minus 3i, and that z2 is equal to the square root of 3 plus I times the square root of 3. And they give us these crazy formulas over here. But in order to use these formulas, we have to have z1 in the form using r's and thetas, and z2 using the same thing. So we have to convert z1 into z2 and get r's and thetas, and then we can put it in this form here. So let's start with z1. So with z1 here, I gotta go ahead and put in pen mode. For z1, in order to get the r, all I really have to do is just do r is equal to, that's the using that Pythagorean theorem form, square root of 3 squared, right, plus 3 squared. So that's just going to equal, that's 9 plus 9, so that's the square root of 18. I think I can, that's 2 times 9, so that's equal to, I can do that 3 times the square root of 2. So that's my radius for z1. And how about my theta? Well, for my theta, now we think about this. In the complex plane, we're going to the right, and then the minus says we're going down. So if we're going to the right and then down, we're in the fourth quadrant. So this means that our theta is in the fourth quadrant. So I can use the inverse tangent. So inverse tangent of y over x, so negative 3 over 3, which is just, remember the y over the x, so that's just negative 1. And if I go to my calculator, make sure I'm in degrees, mode, degrees, and if I don't remember what the inverse tangent of negative 1 is, I can just put it in here. Inverse tangent of negative 1 is negative 45, and negative 45 degrees is sure enough in my fourth quadrant there, right? So I could just leave it like that, or if I wanted to, I could put that in standard form by adding, let's go ahead and put that in standard form just so it looks nice on our unit circle. So let's add 360 to that. 315, so we'll call that 315. That's a coterminal angle, so 315. All right, so that's our theta here for R1. All right, so we got our Z1. So we got our Z1 stuff. So our R is 3 square roots of 2, and our degree is 315 degrees. You could have used negative 45 or 315. You're going to get the same thing. Remember, both those angles are coterminal. Just the 315 is in standard form, so that's on our unit circle. It might make it a little bit easier if you're looking it up. All right, so for Z2, our R is going to be equal to the square root of 3 squared plus the square root of 3 squared. So that's going to be equal to the square root of 3 squared. That's 3 plus 3 is the square root of 6. So we can just pretty much leave it like that. You can't really reduce that anymore. And then for our theta, we're going to be, and this is in our first quadrant here because we're going to the right and then we're going up. Theta is going to be the inverse tangent of square root of 3 over the square root of 3, which is just 1. And that's just going to be a positive 45 degrees, and that's already in standard form for us, so we don't really need to do anything. If you wanted to check that, you could just do tangent of 45. Oops, I'm sorry, tangent of 1, excuse me. Tangent of 1. What am I doing? What am I doing? Inverse tangent of 1. Inverse tangent of 1. 45 degrees, yes. All right. So we have our R, and we should really call this R2. And we should really call this theta 2. We should really call that R1 and that one theta 1, so we don't get those confused between our Z1 and our Z2. And now we really have everything that we need in order to figure both of those out. So let's go ahead and do this first formula, the Z1 times the Z2 that it's asking for. So Z1 times Z2, that's going to be equal to R1 times R2. So R1 is, I hate when it does that. R1 is 3 square roots of 2, 3 times the square root of 2. R2 is the square root of 6 times the cosine of, I'm going to go ahead and add these together, of 315 plus 45, because you just add those together, so that's of 360, 60 degrees, plus I times the sine of 45 plus 15 is 360 degrees. And there we go. So now we just really got to clean this up, right? So this is 2 times 6 is 12. So this is going to be 3 times the square root of 12. We can pull or change the square root of 12 4 times 2. Oh, excuse me, 4 times 3. So I can pull a 2 out of it. So this is going to end up being 6 times the square root of 3, right? That should be the same thing there. Let me check on my calculator just to make sure. So 3 times second square root of 2 times second square root, I am 3 times second square root of 2 times second square root of 6, second square root of 6. And I'm saying that should be equal to 6 times the second square root of 3. And sure enough, if you have a question about it, just multiply them out and you should get the same decimal approximation. So that's what that is. And this is going to be times the cosine of 360, which is the cosine of 0. That's your x value at the angle of 0 is what? That is going to be 1, right? 1 plus the sine there, that's going to be 0. So this whole thing should just equal to 6 times the square root of 3. And that is that part right there. So not too bad once we kind of figure out all of that jazz. And then the other part here, the Z1 all over Z2. So that one is going to be R1, which is 3 times the square root of 2 all over the square root of 6 times, and then we have this mess here, but it's a little bit different. So it's the cosine of this one times this angle minus that angle. So 315 minus 45. So 315 minus 45. And that's 270. So the cosine of 270 plus I, and this, I think I forgot the I out there, but that I just zeroes out over there, right? So we don't have to worry about that. Times I times the sine of 270. 270, like this. All right, and then we're going to pretty much be doing the same thing. And what is the cosine of 270? All right, well, cosine of 270 is 0, and the sine of 270, sine, if you don't feel like looking at your circle, is -1. Is -1. The 270 is the one that points straight down. So then this is going to be equal to, I'm running out of room here, 3 times the square root of 2 over the square root of 6. 0 plus, or actually that should be a minus I, right? So this ends up being negative I times, so I'll probably put let's rearrange that a little bit. Negative 3I square root of 2 over square root of 6. And then we'll need to clean that up a little bit. So times the square root of 6 to get that square root of 6 out of the denominator. So that's going to be equal to, yeah. And I'm going to let you go ahead and clean that up. But you're going to end up having to reduce the top and the bottom a little bit more there. MyMathLab may take this answer here, but go ahead and multiply the top and the bottom by the square root of 6. This becomes the square root of 12 again, which means that reduces again to 2 square root of 3, and then the 2 will reduce with the square root of 6, or 2 with the new 6 on the bottom to reduce that a little bit farther. All right, guys. I hope this helped. I know this is a pretty bestial problem. Let me know if you have any questions, and I hope you have a great weekend. Thanks.